Good morning. Welcome to Physics STPM. Right. So this PowerPoint presentation is prepared for STPM Physics or Physics STPM. A-level student, Cambridge A-level student will find it also helpful. Right? Not everything teach in STPM is required by A-level, but for this topic, it is helpful for them, can be used. Right? For STPM first semester, we go to physical quantities and units. Then under mechanic, we go kinematics, dynamic, work, energy, and power. Right? Same as A level. Circular motion is more for A2 for A level. Gravitation also A2. Static is also required for AS for A level. Deformation of solid AS. Thermodynamic is more for A2. Right? Kinetic theory of gases. Thermodynamic of gases. Heat transfer. Transfer is not relevant for A-level student. Right? Under physical quantities and unit, you will study base quantities and unit, SI unit. 1.2 dimensions of physical quantities, not required for A-level student, but still can be used. Scalars and vectors. Uncertainties in measurement. That is the syllabus for STPM student. Under physical quantities, base quantities, and SI unit. Right? Supposed to list base quantities and their SI unit. Mass, kilogram, length is meter, time, second, current is ampere, temperature, Kelvin, quantity of matter, mole, deduce unit for derived quantities. Right? Under dimension of physical quantities, use dimensional analysis to determine the dimensions of derived quantities. Instead of using unit, we can use quantity. That's what dimension is all about. Check the homogeneity of the equation using dimensional analysis. Construct empirical equation using dimensional analysis. Right? Although these are unofficial textbook for STPM students, right? If you want to investigate what is suitable for you, you should have at least either one of these. Right? I'm using this one, which is very good. Right? You want to consider this one? I'm not sure, haven't evaluated this one, but you must have a past paper. Of course, the updated one, this is the old one. Right? This is for Cambridge A-level 2022 to 24. This is what is required. More or less quite similar to STPM. Okay, base quantity and SI unit. Physical quantities. It can be observed and measured. That's important. Right? You can either use a thermometer to measure the temperature, or we can use a stopwatch to do the timing. Example, mass of car is 2,000 kilogram. Mass is a physical quantity. Car is a thing that you want to measure. Right? Magnitude is, or the size is 2,000. How big, how small? Then the unit is important. It's treating physical quantity, magnitude, and unit. Right? Scientists use SI unit to communicate. With each other rather than conversion of unit. Of course, there are certain countries like America and Brunei. Right? Very few countries still use old foot, pound, catty, all that. But as far as A level is concerned, for STPM, we use SI unit. In physics, we need to make careful observations, precise and accurate measurements. Right? The physical quantities can be measured. Base quantity and base units, they are like the building blocks of a house, the bricks. Right? Stack it up, make whatever shape of the house you want. Building block of physics, base quantity are the building blocks of physics. Base unit, SI base unit are standard unit of measurement defined by international system of unit. There are 7 quantities of what is now known as international system of quantities. Right? 7 base unit, 7 base quantity. They are notably a basic set for which all SI units are derived. So from all these 7 basic ones, we derive all our other units and quantities. Right? So must recognize that, memorize that. Right? Base quantities are the building blocks of physics. There are 7 of them. For STPM and A level, you need to know 6 of them only, memorize them. Each quantity has its own symbol and unit. Right? And each base quantity is defined precisely. You don't need to know about that in a lower form. You have defined it. Right? Length, right? That is symbol L. Unit meter. Symbol short form for meter is M. Then we have mass. Symbol is small m. Right? You just take the first letter of length, first letter of mass. Right? It's just a language by itself, the symbol. And unit, kilogram, kg for short form. Time, symbol, T, unit, second, short form, second. Electric current, symbol is I, capital I. Ampere, small a, because this is unit, not name of a person. But there we put A, capital A, as a different. Right? Because it's name of person, we use as a unit. Thermodynamic temperature, capital T. Kelvin, same, name of a person, small k, and capital K, or symbol or short form. And amount of substance, and mole, right? Short form, MOL. Of course, the 7th one is light intensity, which you don't need to know. But still, it's I, intensity. Candela, CD. Right? So the last one you don't need to know. Right? This is just for your info. Right? Don't need to bother about it. At the end of the 18th century, a kilogram was a mass of a cubic decimeter of water. If we use water as a standard, then we find it's not suitable. Right? Because water have impurities and it changes with temperature. So in 1889, the first CGPM sanctioned the international prototype kilogram. This is a kilogram, specially stock made of platinum, uranium, and declare this prototype shall henceforth be considered to be unit of mass. Right? Don't allow simply anyone to touch it. They probably have to make a secondary and tertiary kilogram to send it to the standards laboratory all over the world. Right? But no one has to touch it. Only after certain time, they want to check the secondary and tertiary, see whether it's the same. Then only under special circumstances, it can be taken out. It has to be protected because we don't want the kilogram to change. Right? This is a prototype. Right? Kept at the International Bureau of Weights and Measure under conditions specified by the society. Right? Now we look at derived unit. We look at base unit. Now we look at derived unit. But basically, we can by length divided by time, or mass divided by length divided by breadth divided by height, or current times time. These are all derived unit, derived quantity. Base unit can be combined by multiplying or dividing. Right? This one divide, this one also divide, but this one multiply, this multiply. Example of base unit is speed, distance divided by time, or it can be velocity. The unit is the same, we are not worried about that. Whether it's a vector or scalar. Distance measured in meter, time in second, so meter per second. Right? This case, base unit divided by base unit. Right? Distance is length. Area, length times breadth. Length is measured in meter, breadth is measured in meter, the unit is meters, meter square. Base unit times base unit. Momentum, defined as mass times velocity. We'll study this later on. Mass is measured in kilogram, velocity is meter per second, so unit is meter per second. Base unit times base unit, divide by time. Base unit. So we must be able to define what's a derived unit, because it derived from base unit. It doesn't help you, it doesn't tell us what it is. Right? These are all examples of base unit that we've just shown you. Consists of a combination. How do we combine the base? How do we derive the unit? We combine the base unit. By how? Multiply together, or divide, or do multiply and divide together to get the derived unit. Right? So these are other examples. Volume, density, velocity, acceleration, force, electric charge, which will be defining it again later on in the syllabus. Right? And we come to prefix and conversion of units. Prefix. Right? Sometimes you have to write large and very small value. So that is where prefix come handy. Example, wavelength. Right? Rather than write so many zeros there, we have prefix, it simplify our life. Right? 780 nano. Nano is 10 to the power 9. So this is 3, 6, 9. 790 nano, nano 9. N for 9. Nano, 10 to the power minus 9. Radius of the Earth, right? Instead of writing so many zero, we can write as 6.5 megameter. Right? This is 3, 6. Now you can try yourself, match it, see what you can remember. Right? Try it out yourself before I give you the answer. Know what is milli, how to match milli, mega, femto, nano, tera. Okay, that's your milli, 10 to the power minus 3. Mega, 10 to the power 6. Femto, 10 to the power minus 15. Tera, 10 to the power 12. Where is capital? Is always more than 1. Nano, 10 to the power, right? Always less than 1 will be small n. Right? So all you need to remember. All this you need to remember for A level and STPM. Used to prefix is to express quantity much larger or smaller than 1. Right, let's try some question. State what is required for measurement. Right, should be able to remember now. Quantity measured must be there. State what you are measuring: mass, time, magnitude, how large it is, and the unit. These 3 things are important. Besides telling us what mass of what, mass of car, mass of boy. Right? Unit of quantity is defined precisely. Right? There are 7 base units. A level STPM, we just need to know 6 only. So all this you need to remember. Right? The six base quantity and unit, memorize it. Okay, test yourself. Which of the following pairs of unit are both SI base unit? Must be able to recognize. Right? So we got C, the answer is right. Mole and second. Newton is a derived unit. Right? Unit for force. Celsius is not SI unit. Momentum is not SI unit. Right? It's a derived unit. So base is ampere, kilogram, Kelvin, mole, second. What is a derived unit? This one you must know how to define. Right? These are example. Derived unit is derived from base unit. That doesn't answer you. Right? Usually examiner, it doesn't have the examiner. How you derive it? How do you call it a derived unit? Do you add or you subtract, divide, multiply, or what? Consists of combination. We combine base unit. How? By multiply together, divide, or both of them, multiply and divide. That's important. It can ask you to find the base unit of energy or dimension of energy. You can use the work, or you can use force and distance. Unit, force is mass times acceleration. Go to the definition. Mass is in kilogram. Acceleration is meters minus 2. So that is your unit for force, which we call Newton. Okay, simplify it. Energy, there is your force times your distance. Right? M to m squared, s minus 2. Power is the same. You can use work done over time or energy over time. Right? You've got energy already. May pay you to memorize it if you want to. They can answer multiple choice question faster. Then divide by time, second. So it becomes kilogram, meter square. Take to the top there, it becomes minus s again. So minus s minus 3. Right? Specific capacity, which you study in your O-level or STPM, you are expected to remember that. Right? So you want to specific capacity in terms of base unit, subject C, Q, M, and theta, take it down. Then, right, remember, unit for Q is energy, which you have derived earlier. M is kilogram, K is in Kelvin. Kilogram and kilogram cancel off. So we got meter square, S minus 2, Kelvin minus 1. What's the base unit of the following quantity? Right? Funny thought, you should be able to do it yourself. Okay, so write down the equation, momentum, square, divided by mass. Right? Cancel the mass off. So you got mv squared. Straight away, you know, this is the side kinetic energy. Right? The unit looks similar to kinetic energy, except we don't have the half missing. Half doesn't matter, half doesn't have a unit. Right? So we can do very fast. If you can recognize this energy, if not, work it out. Right? Force times time. Right? We can recognize it, go straight away. If not, work it out. Right? Mass, force is mass and acceleration, and time is t. Mass, kilogram. Right? You recognize this momentum, or change the momentum, which you study later on. A, meters minus 2, time is second. So simplify kilogram, meter, s minus 1. So you can see this is a unit for momentum. And then you need to play with prefix. Right? They give you an example. Milli times micro is 10 to the power minus 9. Tera times nano. Right? Work it out. Look at your tera is 10 to the power 12. Nano 10 to the power minus 9. So 12 minus 9 is 3. Giga 10 to the power 9. Kilo 10 to the power 3. So 9 plus 3 is 12. Right? That's where we have calculated. Then micro, right? Divide by 10 to the power minus 9. You take the top, become 10 to the power 9. Right? Remember, this is divide. This is divide. I've taken to the top, so it becomes positive. 10 to the power 3. Right? Femto, 10 to the power minus 15. Mega, 10 to the power 6. Minus 15 plus 6 is minus 9. So you want which is the smallest and which is the largest. They can ask you in the exam anything. See whether you can know how to calculate. Right? So the largest is 10 to the power 12. That one. Right? The smallest is donkey. D, 10 to the power minus 9. Smallest D, largest B. Okay. Okay, and try your past year paper for A-level student. STPM can try from your book. Unit conversion is important. Right? 100 milligram, you want to convert it to kilogram. Right? You can do your own way. If you find your own way is easier. Right? Change to scientific notation. 1 times 10 to the power 2 milligram. Then 1 milligram is 10 to the power minus 3 gram. Yeah? Replace that with 10 to the power minus 3. So minus 3 plus 2, you get still minus 1. Right? Simplify it. 10 to the power minus 1. Right? Gram. Now I want to change to kilogram. Right? 1 gram is 10 to the power minus 3 kilogram. So simplify it. Minus 1 minus 3 becomes minus 4. Easy, you cannot avoid it. There's maths there. Your maths has to be good. Right? And you need to be able to change that. Convert it to meter. Change to scientific notation. 2.5 times 10 to the power 2. And pico. But consult your table or remember it. 1 picometer is 10 to the power minus 12 meter. Put it there. And simplify. Minus 12 plus 2 is minus 10. That's your answer. Right? Simplify that. You can try all that yourself. Right? Or convert it to area. A millimeter. Right? You can remember, good. Cannot, work it out. Simple thing you may need to remember this one. 1 millimeter is 10 to the power minus 3 meter. Right? Rewrite that. 1 millimeter, you square the whole thing. Bracket it, square the whole thing. And replace 1 millimeter with 10 to the power minus 3 meter. Put inside there. Yeah, square that. So square that. Minus 3 times 2 is minus 6. 10 to the power minus 6 meter square. Right. After I've done that, convert this one to scientific notation. 7.6 and 10 to the power 2. Then replace your millimeter square with that. Right. Minus 6 plus 2, so you still got minus 4. Okay. Same here, you must know how to convert. This one come under diffraction grating. Right, 400 lines per cm square. You rewrite that in your mass notation. 400 lines per cm means divide by 1 cm. Right? So 4,000 still say that. 1 cm you have to convert to meter. 1 cm is 10 to the power minus 2 meter. Right? So you divide, you count, take to the top, becomes 10 to the power 2. Right? 1 cm is 10 to the power minus 2 meter. Take to the top, becomes 400,000 per meter. Okay. Any comment? Let me digest. Okay. You can also use dimension. Nothing wrong with that if prefer. Where previously we use unit, here we use base quantity. That same as unit, is a preference. A-level student don't need to study this. Mike, you can still use it. Nothing wrong with that. Right? Previously, we use unit. Dimension, we are more interested how the quantity is related to the base quantity. This is base quantity. Each base quantity, we give it a dimension, or we call it a symbol. Right? We use the first letter. And length is L. Mass, M. Capital letter. Time is T. Right? Example, that's our short form. Right? Rectangular bracket, length, L. Dimension of length. Instead of writing the dimension of length, you just put it a rectangular bracket and then L. Right? Length L, mass M, time T, electric current, capital I. Same. Right? Quantity that we use for electric current, capital, right? Instead of T, where it can be confusing, then we change it to theta. Amount of substance, capital N. Right? These are the 6 base quantity that you need to remember. So you should be able to determine dimension of derived quantity and their unit. Right? Go to the formula as always before. Force is mass times acceleration. Right? Dimension of force, M is mass, M. Okay. Acceleration is length divided by time square. Right? Length divided by time minus 2 time square. Kinetic energy, half mv square. Dimension of kinetic energy, M, mass, M. Okay. Velocity of speed, Lt minus 1, 14 square. And simplify L square minus 1 times 2 is minus 2. Okay, so we are looking at dimension. Let you write dimension. You want unit, you can convert it. Mass is kilogram. Length is meter square. This is time, S minus 2. Right? Important unit and dimension, the same thing. We use the idea of homogeneous or dimensionally consistent. Right? Basically, we are just saying when you add, it must have the same quantity that you can add, or the same unit that you must add, or the left-hand side of the equation must be equal to the right-hand side of the equation. That means if the left-hand side is weight, the right-hand side must also be weight. Right? Homogeneous. Each term in the equation must be homogeneous. That means they have an example. Right? That's your equation. V square, right? Either dimension or unit must be the same as U square, must have the same unit or dimension as 2as. Right? That's what I mean by homogeneous. Same unit or same dimension. Right? Dimension of U square and V square are L square, E minus 2. Right? 2as, same thing. Acceleration, L, T minus 2. S is L. So you can see they are the same. They must have the same unit or dimension. Right? Sometimes we forgotten about equation. We can remember vaguely that there's some constant there. And right, it depends on length, depends on mass, depends on G. We don't know exactly, but we know there's acceleration due to gravity, there's a length there, and then it's to some sort of power A, power B, power C. A, B, C are constant. Then we can use dimension or unit to derive it. Right? You can derive an expression to relate physical quantity with other quantities. Right? We will study this under simple harmonic motion. how to derive this equation, right, using simple harmonic motion, but dimension can derive for you this equation, except you won't be able to find for you your 2 pi, the constant, because the constant doesn't have a dimension or unit. Right? Example, right? Our k is a constant, a, b, c, our constant number, just a number. Right? Solution, dimension on left hand side, because dimension on right hand side. Right? K, as I said, it's a number, so it doesn't have a unit. L is length. M, mass, and the power b. G, acceleration, LT minus 2, 14 to the power C. Right? Let's tidy up. This is A, this is 1. Sorry, not 1, L to the power C. So it's A plus C. Mass, M is the power B. And this one minus 2 times C is minus 2C. Right? Thing to remember, any quantity to the power 0 is 1. So whatever one we add in doesn't matter, it doesn't change the equation. Remember, this is the equation. Right? Whatever we do it, the left hand side must do to right hand side. So if we times 1, it doesn't affect the value, it's still t. Right? So we can rewrite that t to the power 1. Right? L doesn't have L, we can call it L to the power 0. We didn't do anything. L to the power 0 is 1. M to the power 0 is also 1. So we didn't do anything. Then we equate. Right? Yeah, use the idea. Unit is the same, or dimension is the same. Left hand side and right hand side is the same. Right? We equate the power of t. I can start with anyone. Right? We want to find C first, easier. Right? Power of, right? That one is 1. That one is minus 2C. So from here we can calculate. Take our minus 2 down, got minus half. Then look at our L. L is A plus C. L is to the power 0. Right? So A plus C is 0. A is minus C. So minus C, C is minus half. So minus becomes half. Same. Right? M power B. B is 0. M is to the power 0. So B is 0. Right? So the two equation becomes to the power half, G to the power minus half. Okay, as I say, we cannot find the constant because it doesn't have a unit. That's the weakness or shortcoming. Okay, and try the others. Okay, and try 1 or 2 questions before we stop. Given F equals to K and RV, what is the unit of N? Right, you are told that F is a force. This is eta, coefficient of viscosity. Any equation can come out as long as I explain to you. Radius of a body, V is the speed of a body. Right? K, they have to tell you, is a constant, a number, no unit. Right? Remember, the equation is homogeneous. So we can subject, first thing is to subject your, right? Know the quantity for each of them. Or dimension, doesn't matter, quantity or dimension. Unit or dimension, right? Force, derive it, you can remember it so much the better. Speed or velocity, meter s minus 2, minus 1. Radius is in meter. Then subject, right? Take R, K, and R to the cross multiply to the bottom there. F, right? That's your F, unit. K, no unit. R is in meter. Speed, meter s minus 1. Simplify kilogram. Meter and meter cancel, there's still a minus divide by m minus 1. And this one cancel off, is still got s minus 1. Right? This actually Stokes' law, which you don't need to know. You only need to know that your F is proportional to V, air resistance. Right? Air resistance is proportional to V for low speed or low velocity. Okay, so this is just to redo what we have just done. Right? Replace V, replace radius with that, K non-unit, and then simplify them. Right, M and M cancel off. Right, S minus 2, cancel, you still got minus 1, and get the answer. Right? Or you can use dimension, doesn't matter. As long as you can get the answer. Right? Same. That is the dimension. Speed, that is the dimension of speed. Radius is length. Right? K non-unit, no dimension. Okay, that's your force F. Then you have your length and T, mt minus. Sorry, this one should be get confused with meter. Length. Right, speed is length divided by time. Right? LT minus 1, then simplify L and L cancel off, you still got 1 divided by 1L. Minus 2 cancel with minus 1, you still got minus 1. That's the answer. Right, can try this one. The speed V of liquid leaving a tube depends on the change in pressure and density rho of a liquid. The speed is given by the equation. K is a constant that has no unit, so don't have to worry about K and throw it off. So to find the value of N. Okay, we'll study pressure and that pressure later on. Right? Pressure, we've forgotten, derive it, the unit or the can work with unit or dimension. Okay. Height, meter, density, kilogram, meter minus 3, acceleration, meter s minus 2, so kilogram, no others, so kilogram is 1, minus 2, minus 3, plus 1, so you still got minus 1, right? S minus 2. Replacing the quantity with unit or dimension, same thing, right? That's your speed. K you can throw out, just a number, doesn't affect our calculation. And pressure, you got that, that's our pressure. Density, mass divided by volume. Okay, and simplify it. Right? Kilogram cancel off. Minus 3, take to the top there, becomes, take to the numerator, becomes plus 2, and times n, power n, and s minus 2 times n, s to the power minus 2n. Okay, so equate them. Remember, m understood there's a 1 there, or you can equate s, the power of s, same thing. Right? 1 here equals to the power n, so n is 2, it's half. So answer C. Sorry, A, not C. I can use, as I say, using dimension, same thing. Replace it with dimension or quantity. That is your density. This is your acceleration. Right? Same. Speed, dimension, pressure, that's your pressure. Right? Mass divided by volume. And simplify it, get the same answer. Okay, doesn't matter, whatever convenient for you can use it. Okay, remember that all these things you need to remember. So we will stop for today. Thank you for your time.